Hey there, in this video, let's look at the concept of potential. Let's start off by taking an example of a freely falling body. Here we have an object having mass m. The body having mass m is placed at a height h above the Earth's surface. We all know that the average acceleration due to gravity of the Earth is 9.8 meter per second square. And the potential energy of an object as you move it away from the earth, the potential energy of an object should increase. The formula that you have learned was that potential energy is equal to mass times gravity times distance from the earth, h. So over here, if this object under consideration is at a height h, the potential energy is mgh. So a body that is left freely to fall from a height h is going to move from a higher position to a lower position until it loses all this potential energy. So from this example, we saw that a body under free falling condition will always move from a higher gravitational potential to a lower gravitational potential. That is, from a higher to a lower gravitational potential. In our next example, let us take two tanks that are connected and filled with water with different levels. Here are our two tanks with water having different levels in both the tanks. We can safely say that the difference in pressure between these 2 points is going to cause water to move from, say, tank A to tank B. The difference in level is this, and that means that the pressure at this point is equal to the pressure at this point in vessel A. The excess pressure due to this difference in height is going to cause the water to flow from vessel A to vessel B until the level in both the tanks become equal. There, now you see that the level in A has reduced, and at the same time the level in B has increased till the point of time the level in both of these have become the same. This is due to the concept of hydrostatic pressure. Hydrostatic pressure. That is, the water will flow from a container having water at a higher level to a container having water at a lower level, irrespective of the quantity of water in both the containers. Our next example, where we'll be looking at potential, is when two bodies at different temperatures are brought together. So if I have two similar bodies but at different temperatures, like in the case of this figure where the warmer body is at a temperature of 60 degrees centigrade while my cooler body is at a temperature of minus 10 degrees centigrade, we see that the body at a higher temperature begins to lose heat and supplies that to the body at lower temperature. Since both of them are made of the same material, we can safely assume that the final temperature of both these bodies is going to become 25 degrees centigrade. That is, the amount of heat that is lost by the body at a higher temperature will be equal to the amount of heat that is gained by that at a lower temperature. So we can see that the difference of the temperature 60 and minus 10 would lead us to a final temperature of 25 degrees centigrade. This is achieved by the process of conduction, and we observe that the takes place flow of heat takes place from a body of higher temperature to a body at a lower temperature. Now, in our last example, we take two charged metallic conductors. Here we have the two conductors, and let us call them conductor A and conductor B. Let's say that A has an excess of electrons, has a negative charge, while that of B has a deficiency of electrons, hence it is positively charged. So now that we have our two metallic conductors that have different charges, by some means of an external wire, let me connect conductors A and B. We already saw that there is excess of electrons over here. We have excess of electrons in A, while in B we have a deficiency of electrons. Now, because there is an excess of electrons in A, the electrons in A move via the wire to B to negate this positive charge. So, my electrons begin to move from A to B. We already saw that electric current is in the direction opposite to the flow of electrons. So, how would the electric current move? It would move from B to A. This is my electric current. We say that an excess of electrons is at a lower potential, while a deficiency of electrons, which is causing a net positive charge, is at a higher potential. So, how does the flow of electrons and the flow of the electric current move? So, we see that electrons move from a lower potential to a higher potential. See, body A is at a lower potential, body B is at a higher potential, and electrons is moving from A to B, so lower to higher potential. While the electric current moves from a higher potential to a lower potential. So at this stage, we can define the word potential. So we define potential as the electrical state of a conductor which determines the direction of flow of charge when two conductors are either kept in contact or joined by a metallic wire. Important things that you should keep in mind about potential. 1. It depends on the concentration of charges on the conductor. It depends on the concentration of charges on the conductor and the size and shape of the conductor. Size and shape of the conductor. These are two important things that you need to keep in mind. So to summarize this video, if you have two charged bodies, one with an excess of electrons, and the other with a deficit of electrons, what happens is the electrons from the body, say A, start moving towards the body B. This is the flow of electrons. while while electric current flows from B to A. This is the direction of flow of electric current. The body that has a deficit of electrons is at a higher potential, and those with the excess of electrons is at a lower potential. So flow of electrons takes place from a lower potential to a higher potential, while electric current takes place from higher potential to lower potential.